Imagine, when something comes into contact with a matter, they annihilate each other, releasing energy. And the process would be 100% efficient in converting mass into energy, unlike nuclear fission. Hi fans of technology, welcome to Newtech. Today we will explore what antimatter is, its potential uses and the challenges it presents. These days, antimatter has been captured the imagination of writers and filmmakers, often portrayed as a powerful energy source or a devastating weapon, as seen in the movies like Angels and Demons and the Star Trek series. Do you know what is antimatter exactly? It is the counterpart to the matter that makes up the world around us. For every particle that exists, such as an electron or proton, there is an antimatter counterpart with the same mass but opposite charge. For instance, the electron's antimatter equivalent is the positron. When matter and antimatter meet, they annihilate each other in a burst of energy. This process, known as annihilation, releases energy according to Einstein's famous equation. M times c in power of 2 is equal to E. This means even a small amount of matter and antimatter can release a tremendous amount of energy. The laws of physics dictate that the energy of the Big Bang, which shaped our current universe, must have created equal amounts of matter and antimatter. In other words, any reaction in the universe that produces a particle of matter should simultaneously create its corresponding antiparticle. Therefore, the absence of antimatter in the present universe is considered a mystery. One of the most significant challenges for physicists is to solve the puzzle of why there is an asymmetry between matter and antimatter in the universe. Now I'm gonna tell you that the idea of antimatters is not very old. The concept of antimatter was first proposed by physicist Paul Dirac in 1928 through his work on the equations of quantum mechanics. It wasn't until 1932 that Carl Anderson discovered the positron, the first confirmed antimatter particle, while studying cosmic rays. As I told you earlier, antimatter has long fascinated science fiction writers, often depicted as a powerful energy source or weapon. However, in reality, while it holds great potential, the challenges of producing, storing and utilizing antimatter are enormous. However, in reality, while it holds great potential, the challenges of producing, storing and utilizing antimatter are enormous. You want to produce antimatter? Not easy. Producing antimatter involves using particle accelerators to accelerate particles such as protons to near light speeds. These particles are then directed to collide with the targets or each other, resulting in high energy collisions that can create particle-antiparticle pairs, such as positrons and antiprotons. The energy from these collisions converts into mass, producing the antiparticles. Since antimatter annihilates upon contact with normal matter, it must be captured and contained using specialized devices like magnetic traps and penning traps, which use magnetic and electric fields to hold the antiparticles in a vacuum. Antiparticles are often cooled to make them easier to contain and study. However, producing and storing antimatter is extremely challenging and costly, as only tiny amounts have been created primarily for scientific research, medical imaging such as PET scans and potential future applications. Despite its promise as a potential energy source due to the large amount of energy released upon annihilation, the practical use of antimatter remains far from feasible due to the immense challenges in production and containment. Now, you may ask why we are producing the antimatters, the potential applications. Antimatter could revolutionize energy production. A gram of antimatter could theoretically produce energy equivalent to about 21.5 kilotons of TNT. However, the cost and difficulty of producing and storing antimatter make this application far from practical with current technology. There is one important thing to share here. An antimatter weapon, theoretically, is a device that uses antimatter as a power source, propulsion, or explosive material for a weapon. Currently, antimatter weapons are extremely expensive and unreliable, making them impractical for warfare. The production of antimatter is estimated to cost $6 billion per 100 nanograms, and the amounts produced are very small. Additionally, current technology has significant difficulties in containing antimatter as it annihilates upon contact with regular matter. One of the most promising uses of antimatter today is in medical imaging. Positron emission tomography or PET scans use positrons to detect abnormalities in the body, such as cancerous tumors. Antimatter propulsion is a concept that could potentially shorten travel time to distant planets. An antimatter rocket could be much more efficient than chemical rockets. However, this remains a theoretical application due to current technological limitations. Some researchers speculate that antimatter could be found naturally in certain regions of space, such as near pulsars. If so, it could potentially be harvested for use in advanced propulsion systems for space exploration. There are many challenges and risks for producing antimatters. Firstly, I want to tell you that producing antimatter is incredibly expensive. Estimates suggest that a gram of antihydrogen could cost around $62.5 trillion. Can you imagine it? Secondly, as mentioned, storing antimatter safely is a major challenge. Even a slight failure in the storage mechanism could result in a catastrophic release of energy. Last but not the least, the potential for misuse of antimatter, particularly in weapons, raises significant ethical and safety concerns. While we are still far from harnessing antimatter for practical applications, research is ongoing. Antimatters represents one of the most intriguing frontiers in modern physics. The journey into understanding and harnessing antimatter is still in its early stages, but it promises to push the boundaries of what is possible. Thank you for joining us on this exploration of antimatter and the technology. Please give your opinion.